streaming. Okay, we're live on
NBC News.
No.
Tushar streaming.
It's 6 o'clock.
Live streaming from HP Auditorium.
Live stream from
We should live
HP.
stream it like on
Live
Facebook
stream
too and
of
title it like Milo Protest. It's just like
refugees.
Tushar.
Why?
Tushar giving a get workshop.
Why though? Why must you do this to me?
Full publicity. Yeah, dude.
Oh.
Dude,
No
those
one's
are
gonna,
the
no
best
one's gonna
right
click
now.
on Get Workshop.
Yeah.
They're gonna click on
Okay, someone told me to say this, so I'm gonna say it. CSUA lecture number 2. This is the Git workshop. Announcements. Announcements.
We don't have any announcements.
CSUA events coming up soon.
We do have CSUA events coming up soon.
You should come.
Is that my phone?
Yes, it is on.
So this is our second workshop, and then we have LaTeX next Wednesday. Whoa. Wow. And then in terms of other CSUA events, we have tomorrow afternoon, Groupon on February 7th during lunch, and then IBM workshop on IBM Watson also on the 7th at
Yeah. Yeah. I'm gonna do that to be like John Nero. So, I'm gonna be teaching Git. So, first question, which hopefully everyone is somewhat familiar, but if not, I will answer it all. So, what is Git? It's a version control system that is the actual code for the version control system is open source and it's distributed. So, does anyone not know what any of these terms mean? Ben.
what's distributed?
Distributed means that when you have code that you're checking into and out of repositories, then when you check out the code, you have the entire history with you. You don't have to go back to the server to ask for previous history. You have it all of it downloaded. That's what distributed is. Rather than having a centralized server, like there's two models, the centralized model and the distributed model. So rather than having a centralized server, all the data is given to everyone. Everyone has copies. So, so bolded, open source. You guys know what open source software is, hopefully. The source is open. You can literally download all of the source code for Git. It's distributed. So, what I was trying to get at there is that. There we go. So everything is really fast because to do operations locally, you do not have to talk to a server or to commit. Which I'll explain later what that is if you don't already know. To commit, to go back to old versions of your code, you don't have to talk to a server. You have it all downloaded, so everything is really fast. And then every time you download a repository, you have a full clone, a full backup. So even if your server gets like nuked or something, you still have everything on your local copy. This is not the case in centralized systems in which you only check out a little piece, the piece that you need, and then you send it back when you're done. In this case, you have a full copy. And the good thing about this as well is that you can work totally offline. So if you're like in one like 61A or B or C and you're like coding and you don't have an internet connection because you're on the bus, you can still code, and then when you're done, then you can still commit and everything. The only things you can't do are sync up with the server, and that you can just do later. So everything is fully copied to your computer. Yep. So yeah, all of the history and everything else that's stored there, everything that we'll get into, all of the different data structures that Git stores, everything is copied to your. So you don't just have a copy of the code you're working on, but you have the whole infrastructure of these are all the people who have worked on it, these are all of the changes that have ever been made, it's all copied. Any other questions on this? Okay. So it's designed to be very fast. This is the Linux Penguin. It was designed, so Git was designed by Linus Torvalds, who was the same guy who wrote Linux. He wrote Git because people got mad at him for using a closed source repository system, version control system for Linux, then he just wrote his own because it's Linus Torvalds. So it's immutable, and do you guys know what immutable means? Yeah.
It means you can't change it.
Yeah, so it just stays the same. So it's not that it doesn't change exactly in this case, but it means that it doesn't delete anything. So you never lose any information, and as long as you're using the proper commands in Git, you will never lose a single byte that you type into your computer. It'll all be there. So it's very useful for getting back to old versions of your code, no matter how old it is. And even if you're working on multiple different possible directions that you want your code to go in, you can store them all at once in Git. And we'll be going over all of that. Yep.
I was kind of wondering this, but how memory efficient is Git if you have a huge...
Very. So if you have, do you know what a branch is? Okay. For anyone that doesn't, I will go back to this, but just to answer the question right now, if you have one branch with like a gigabyte of code, and you have another branch that's similar but also has a gigabyte of code, and you change branches, it takes a couple milliseconds to do a branch switch, even though if you had actually like copied or deleted everything and then copied in the new code, it would have taken several seconds to do that. It's significantly faster than the operations would lead you to think, because it uses all sorts of optimizations under the hood to make things essentially not take any time at all. From your perspective, when you type commands in Git, they exit immediately. They don't take much time to move data around and stuff.
And it's like how memory efficient is it?
As in hard disk space. So the Git repository will have to be at least store all of the entropy in your repo. So if you make a lot of changes, then it's going to add more space to the Git repo, but it doesn't add any more than the deltas that you are making. So if you make one change, it won't make a new copy of your code. It'll just make the original copy, and then it'll store the difference. So it's very efficient, and we will go over that eventually. So there's this model called the patch model, which people used to use a long time ago, where they would just write up their code and then publish it, and if someone had a change they wanted to make, they would send you what's called a patch by email, which is just a file that has all the differences between your file and their file, and that way they can contribute to your code by just emailing you a patch, and you can apply that patch on top of your code, and it'll play over your code all of the changes that someone else did. So it's basically like a list of steps of how to go from the original code to the new code, like insert this line here, delete this line there, whatever it is. But in Git, the way that it appears to you is as a snapshot. So it's getting into something different, but a snapshot as in when you commit your code in Git, then it looks like it's a full snapshot. It works about the compression and storing things efficiently under the hood, but to you, it looks like you have a bunch of snapshots where this is what my code looks like today, this is what my code looks like tomorrow. You don't worry about, okay, this is the difference between this and that. It looks like it's storing different entire copies. It's not under the hood, but you don't have to worry about that as a Git user. Any questions about that? Okay. So the way that the compression works, just very high level, just so you guys get an understanding, is that there's delta storage. So delta from physics and math and stuff means change. So it will store in commit 1, when you make a commit, that's like a snapshot, it'll store file A, file B, and file C, let's say. Then in commit 2, let's say you only change file A and file C. It's not going to make an entire copy of file A and file C. It'll only make a delta, which is the differences. So delta 1 means the differences from commit 1. To you, it appears that, and Git makes it appear that it's a full snapshot, but under the hood it's not, because that would be extremely inefficient. But if you had to worry about every little delta while you were coding, that would be really complicated. So instead, it makes it appear like every commit is its own entire copy of the whole repository. And you can keep making deltas, and it'll store them very efficiently like this, where at each commit it only stores what's needed, changes from the previous one. and snapshot storage is what that looks like, where it will store full copies of the code, and so the snapshot model is file-based, so it will worry about the entire file. So Git will make it appear to you like they're storing snapshots, and then so they will actually store snapshots. Like they'll have, okay, file A1 is the changed file, but then they'll compress it and turn it into something that's much smaller. So I see confused looks on people's faces, but since you guys don't know any other version control system, I'm not going to go over this part because these parts are comparisons between someone who knows an existing system and someone learning this one. So, okay, I'll skip to this. So, does anyone here know or not know what branching is? Okay, so most people. So what a branch does, or actually, let me go back. Does anyone not know what a commit is? Okay, so everyone knows what a commit is. So committing is essentially taking a picture of your code right now. So the biggest feature of commit is cheap branching. This is what I was telling you about, that if you have a test repo and this command tells you the size of the repo, it's 78 megabytes. Now, and I'll go over these commands in detail later, but just as an overview, now you switch to a new branch, it only took 91 milliseconds, even though this is some giant repo that you're switching branches in. So a branch is, so you can have a series of snapshots of your code, but let's say you also want to move in a different direction at the same time, making some other feature and seeing which one's better. You'll different copies of your code, right? In which one you're developing feature A, and in another you're developing feature B. So you'll make up two branches, and they're called branches because they will branch off from the commit, and it'll say, okay, this commit goes in and makes feature A, and this commit goes and makes feature B, but I don't want them to go together. I want them to go in two separate directions. So it's called branching, for like literally branching apart. Does that make sense to everyone? Yeah. Yes, there will be two copies of changes because you've changed one way in one direction and another way in another direction. But Git uses very efficient data structures under the hood to keep the total size small. So that's why when you switch branches in Git, it takes almost no time. Copying 78 megabytes would likely take a second or so on a computer, but this one only took 91 milliseconds, even though it was moving around lots of data, because it uses efficient algorithms under the hood to make sure that even if your two branches are totally different code, like you made this branch and then you started making all sorts of features in this direction and completely orthogonal features in another direction, it still won't take a long time to switch between them because it uses a lot of efficiency. So if they're totally different files with absolutely no similarities, then it will take a little bit longer. But even then, it uses some clever file hacks under the hood to say, well, I have a copy of the file here, so I don't need to copy it into the repo. I'll just rename it. So it does a little bit of tricks like that. But you don't entirely need to understand how it does it, but it does make things significantly faster than like if you were manually storing, like, you know how in like high school English or something, if you had papers, you would write like essay 1, essay 2, essay final, and like people would make tons of copies of their documents because they're not sure when they're done, and they're like, oh wait, I have this change. So Git is much more efficient than that. And if you did that with your code, it would quickly become very, very complicated to manage. So the Git algorithms will compress everything for you, store them very efficiently, make switching between different versions very fast, and let you keep all of the copies of everything without like blowing up all of the disk usage. Does that make sense to everyone? Is anyone confused? Okay. And then, okay, so here are some real commands that you can run. So if you have a laptop, then you can run this. If not, then don't worry about it. You can listen to my explanations. So these commands are just the basic configuration starting out, and you need to set your name and your email so that it can write you as the author for the commit. Because now when you push your code to some online repository, then it needs to have the names of each people who made each change so that you know like who to contact for this code or that code. So you put your name and email, and this is also how when you submit code to Berkeley CS classes, then on the other end it'll have your name on it and your email address. So this is a permanent setting. You can run this again later if you want to change it, but for once you run it, it just sticks like that. You don't have to keep running it every time you use it. So is anyone confused on how to run this? Yeah.
I was just wondering if you could give us an example of branding.
Yeah, so I will go into that in a little bit. That was just a very basic overview of what I'm going to go over, and we're diving in now, so I will get to that. If you found anything confusing in the introduction, then when I get to the detailed part, then you can ask more questions on it, and I'll clarify anything that's confusing. So, is everyone done running it? Okay. So now you need to make a repository. So if you make a new directory or folder, then go into it, and you can type git in it, and this creates a blank repository. So now in your freshly created folder, you now have a git repository initialized. And this just creates the basic data structures for Git for it to be able to start figuring out what all the changes are and everything. Any questions about this? Okay. Anyone not done? Okay. I see some confused looks. So is anyone having trouble with this?
Go back to first slide.
Which slide?
First.
This one?
Yeah.
Okay, yeah. If you've used Git before at all, you probably have this configured. If you do it again, it won't do anything bad. Yeah.
Is there a way to see if I've done this before or not? Like, is there a way to say, like, display my name or something?
Git config minus
Minus list.
list? Probably. That sounds right. Yeah, I mean, yeah, you probably do have it if you've ever used Git, because this is the first thing everyone does when they start Git. You can't make commits until your name and email have been set.
Ah, yes.
Can you explain what is a repository?
Yeah, so a repository is basically it's a directory that contains all your code, and it contains a special folder inside it called .git, which you don't ever have to enter that folder and look at what's in there, but it stores all the data structures for Git, and then this entire folder is called a repository, and it can be cloned onto other computers and pushed onto servers and stuff very easily because of Git commands. Once you are inside a repository, then Git knows how to do everything. When you're outside a repository, Git has no idea what's going on because you're not inside a directory that Git has all of the information about. So this lets Git know you want to start using the Git system in this directory. Any other questions? Okay, I'll move on then. So now if you run this command, then it will create a new hello world file. Does anyone not have a Linux or Unix shell running, that or git bash or any of those kinds of things that you can use to run these commands? Okay, so then these commands should work for all of you. Yeah.
What is the RB file?
So, so touch hello-world.rb in general just creates a blank file. So right now it doesn't have anything in it, and RB is Ruby, which I don't even know Ruby, but that's what this slide has on it. So we'll go with it. These aren't my slides. No, these are slides I've been using from online because they're much better than what I could create in the limited time I have. So I just would rather use this. Don't repeat yourself. Use a library if you can. So this is like my library. So once you've created a file and made a repository, this is what the repository looks like. So you don't actually need to know this for using Git, but I'll just like quickly explain what's in here. So it has a head which says what's the current commit that you're on. It has all the branches, your configurations, a description of the repo, and then all of the objects and references that it needs to store internally. That's all of its data structures. You don't ever have to even go inside this folder, but if you typed -a, you would find that you do have this folder created now that you ran Git in it. And then of course you have your hello-world.rb, which is outside the .git folder. So .git is just a hidden folder that's used to store all this repo information. Yep.
Wait, is there someplace we need to go before we can call it tree.a? It's not
In the directory that what shell are you running? Okay. So have you run Git init?
Yeah.
Okay. And then did you run tree.a?
It says command not found.
Okay, that doesn't have it. It's not a big deal because this is what it would look like anyway. It would just show this. And as you can see, it has .git and it has your hello-world.rb file that you made. Yep. Oh, okay. So tree is a command that makes a nice ASCII picture like this of your directories, and not all systems have it. Sometimes you have to install it explicitly, and it's not worth installing just for this because it literally just shows that. So that's why it might not have worked. If it did work, then you could have ASCII picture directory. That's really it. And then the other thing, so this is a local repository, but the other thing you can do is clone a remote repository. So that means that someone has a server on which they've placed a repository that they've made available for download, and Git can just go and get the whole repository, including all of its history. The reason you wouldn't just download like a zip file of all their code and stuff is because it doesn't have the history with it. If you clone a Git repo, you get all the history, all the changes ever made, and you can look at them and see the progression of the code. And if there's multiple branches in which someone's working on different features, you can see all of those too. So the git clone command. So this guy that wrote this slides has a repository with some stuff that you can like play around with. So if you run this git clone command, it'll download his repo, and it just has some random files that he created and branches so that people could look at what a git repo looks like. It doesn't actually have anything legit in it. Yeah. And don't run this inside your Git repository because then you'll have nested Git repos, which doesn't work. So you'll have to go outside your repository and run it in a separate place. But it'll automatically make a folder called grit because that's the name of the repo. So if anyone has trouble running this command, just raise your hand. Yep. What happened?
Is there a way to delete the Git or the folder that we downloaded if you put it in our Git repository?
Yeah. Do rm space -r space and then the name of the folder. Recursive. Because it may need to, if you have folders inside folders, it has to recurse into them and make sure they're all deleted. Yep. What was The link doesn't work.
Git delete.
What was the problem?
When I run this command, it says unable to connect to GitHub.
Oh, then you probably are not connected to the internet.
Do you guys want if there are like people asking questions, we can like get them out.
Yeah, that would help.
That's the
Yeah.
commentary is not.
Just to make things faster.
Did it work for you? No?
Yeah.
Okay.
If you have any questions, raise your hand and then someone
Also, put your thumbs up if you're ready to move on, and I'll just take note. Okay. Yep.
I was just kind of wondering what is good. Sorry, how do you delete this to
What was that?
delete Git in it?
rm minus rf dot git. What was the question?
Repeat your question.
Can you raise your hand if you're not done? Okay, I will move on to the next step then. Don't fall, Ben. Okay, so this is what it looks like. So if you go into the directory, if you didn't put in the command that I gave you, it would have just been called grit, the folder. So if you go into that folder and look what's there, and there's some stuff that this guy made. All these files. So anyway. Ben, Caleb, are you guys still having issues there?
Change the Git colon to HTTPS.
Okay. And Ben, are you still having trouble over there?
I should be
You're good?
I should be fine.
Okay. So now if you're in this directory, you can see not only the files, but if you do git log, then you can see their entire history of every change they've ever made. So I can actually follow along. So maybe that will make more sense. Okay. Scroll down. I don't even remember what the URL was. Alright, so I'm just doing the same thing that you guys already did. So now you can see all of the files they made. And not only that, you can see their history if you do git log. You'll see every single change that's ever been made to this repository. and it's a very long list because apparently this guy's been working on it for a long time, since apparently October 2007. Yep.
How do you go up and down in GitLog?
You use the up and down arrow keys, and then when you're done, you press Q to close it. So the up and down arrow keys let you scroll up and down in this history. Is anyone not able to see this on their computer? Okay. So you can see the log, and on top of that, you can see all of the branches they've made. Type git branch. Okay, git branch minus a. That shows all of the branches that you have downloaded and all of the remote branches. So the reason that the other ones are in red are because we haven't downloaded them yet. They've only been, they're on the server, but we haven't looked at them. There's an easy way to download them, which is to just switch to the branch. So to switch to a new branch, or to switch to an existing branch, you do git checkout, and then the name of the branch. You can just, there's two extra branches there, GH pages and integration. So you just switch to one of them, and now you're suddenly in the integration branch. Yep.
How do I get out of the up and down mode?
You press Q for quit. Yeah. Oh. So yeah, so now that I've switched to integration, I now have a different copy of the code which may be at a different state than the main branch. If you look at the history, they are different because this one is at a different place than the other one in the history. When you do git log, it only shows you the history of the current branch that you're on. Is anyone confused at this point? Yep.
So git branch shows you the current branch?
Git branch shows you all of the branches. Git branch shows you all of the branches that you've downloaded, and git branch minus a shows you all of the branches, including the ones you have not downloaded. So, well, not that you haven't downloaded them, but that you've never used them. So they're in some archived state. But once you check out one of the branches that are there, then it will make the appropriate stuff so that you can start changing that branch. Because up until when you have this remote thing, you so far have not yet made any changes to it or even looked at it. So it's in some archive state. Is anyone else at this point? Does someone want to tell me what they've learned so far, so that I know that you guys actually understand what I said? Ben?
Learned about branches and dash A.
Branches and dash A. Do you understand what a branch is?
A branch is a copy of the files that you're working with.
Yeah.
You have multiple branches, hence copies, that are making slightly different changes at a time.
Yeah, exactly. So this is an example, a repository that some guy is working on apparently, and you can look at all of the files just like a regular directory with normal files in it, so you can read what's in them. There's probably some Ruby code which I don't understand, but it's there. He's doing something. So this is what a repo looks like. It just has regular code in it, and you can interact with it as you would anything else. But if you make a change to it, and I'll demonstrate this right now, and then in a second we'll switch back to the repositories you all created, and you can make your own files. But I'll demonstrate that if I just make some change in which I type a bunch of code, then ask git for the status, it sees, I've modified grit.rb. And if I ask it what I changed with git diff, and I'll go over these commands in detail, but first I just want to show a demo. If you ask what you changed, it tells me in green. I added that line of garbage that I just typed. And then there are a lot of slides in here I'm not going to use. But anyway, if you go back to your repo in which you made that hello world.rb, then and you should have already done the first two commands, but now you can do the third command, git add dot. So git does not keep track of a file until you explicitly tell it you want it to keep track of that file. It'll notice it's there, but it's not going to save the history until you add it to the git repo. So that doesn't do anything to the file. It just tells git, I want you to track this file and its changes.
Does it matter the order? Does the order you enter the first two commands matter?
No. One of them creates the hello world file and the other one creates the .git directory, but it doesn't matter which order. Yep. Dot means the current directory, so that means it adds everything in the current directory, which is just the hello world. It won't add its own .git repo because it knows what that is. Yep.
Is it the same with dash
A? What was that?
Is it the same by saying like git add dash a?
Yes. Git add minus capital A.
Yeah.
That will do the same thing as this. Yes.
And also we have to be in a different directory than the one that we were and create this file and then start a new repository and add it, right?
So this is. Did you create this one already in the previous exercise?
Yeah, but I think we're in the same file.
Oh, okay. So if you make a new directory that's not inside a Git repo, like a completely separate directory, then run these, then you'll get back to where we are. So the current state now is that Git sees one file, hello world.rb, and it sees, oh, you want me to track this file, but it hasn't seen any changes or made any snapshots yet. It does not have a backup of your files at this point because all you've done is tell Git, I want to track it. Now to make a snapshot, you have to make a commit. That's what a snapshot is, or a commit is. It's a snapshot. So now if you do git commit minus m just means message, and then you can put a message there like first commit or whatever you want, and that'll go into that log that you saw for that other guy's repo that has all of that random Ruby code in it. So that all of those messages are in order to make it clear what you changed at each step, so that when you go back and look through the log, then you know what happened at each commit. So does anyone need more time for this?
For every repository, I need to create the name.
W-
Do the
for every repository, or
yeah. So it asked me to enter the name and the email again.
did you already enter it?
Yeah.
Or, oh, okay. Let me take a look. 'Cause I don't.
So why is it? Maybe is it different directly?
No, it's stored in all of them. Oh, I don't know that ran the command. I just looked for the command history. It's there. If you just run that.
Oh, because I closed the terminal.
Oh.
This is considered undo.
Oh, you will not normally have to retype that. Okay. Anyone else not done with this? Okay. So I'm not going to dwell too much on this, but inside the .git repo, inside the .git folder, it's created some of its long, complicated hash values to store all of the data that you just committed, and you don't really need to worry about the internals of it. But moving on to how to actually use this. So what you will want to do is, after you've added your files and made your commits of like your empty files so that they're at least there, then you want to edit your files to add all of your code, stage the changes, review your changes, and commit it. And I'll go through each of these steps. But where is? Okay, so when you're so editing the files is just with your editor or whatever you do to write your code, IDE or anyway. Then staging the files, you have to run add again, so that git add, once the file already exists, then running git, or once the file has already been added to the git tracking system, then running add on it again means that you're staging it. So hopefully there's a picture in here. Ah, yes. So there's the working directory of your project. That's all of your files. And just creating a file is not enough for Git to see that there's a change. Well, it'll see that there's a change, but it's not enough for Git to register that change into your repo and save a copy of it. Because otherwise, every single time you hit save, it would make a new copy, which would be very expensive. So instead, when you're ready to tell Git, okay, I want you to actually save these changes, you have to stage them, which just means running git add on the files again, and that'll tell Git, okay, I've changed these files and I want to actually save these changes for only these files, because you may have changed multiple files but want to not snapshot the other ones yet because they're not ready or something like that. So you may only want to save one file. So staging is the equivalent of adding something to your new snapshot. And once you've added it to your snapshot, you create the snapshot. Once you're done saying, okay, I want this in it and I want this in it, then you make the snapshot. And it only stores those changes. So if you open up that hello .rb file and you just type something in it, it doesn't have to be actual code. Git doesn't read the code, it just looks at the changes. So if you open up that file in like Notepad or something and you type something in it, then it'll show this the next time you type git status, which tells you what's going on. It'll say changed but not updated. So can you raise your hand when you get to this state so I know that you're done? Okay. Which steps? This one? Oh, we didn't do anything yet. I was just explaining. This one? Yeah, so we're going through that now. This was the diagram, but here are the actual commands. So once you've changed your file, whatever you're modifying, I don't know why this guy changed from hello world.rb to main.py, but like whatever file you're changing, it gets listed here as modified. But now it's only been modified. It hasn't been staged. Staging is what tells Git that I want this modification to be saved. So it tells you exactly right here how to tell Git that. It says run git add and then the file name. So if you run that, then it'll add it. Anyone not done with that? Okay. So now there are a lot of animations in this. There we go. Okay, git add, it's red because if you don't do this, then Git will not track your changes, and that will be very bad if you mess up your code because Git will not have the history for it. So you have to do this. This is very important. And this is the single most forgotten step because there's editing and there's committing, yes, but there's also adding. And adding, which is the staging part, is really important. So when you do git add, then Git has an index that's storing like, okay, these are the changes that I'm gonna prepare to commit. Then git add just tells Git, okay, index this change and prepare to make a commit. Because when you actually make the commit, all it does is finalizes the index and says, okay, this is done. I'll put the finalized stamp on it and say this snapshot is permanent and it's not gonna change anymore. But before you do that, you have to make sure that you git add. So once you add a file with git add, then it looks like this. It'll say changes to be committed. And you can undo that add with the command it gives you. Git is very helpful in that it tells you exactly how to use it as you're using it. But it tells you changes to be committed and then what you modified. So this is where you should be at now. And this is an overlay because it says changes to be committed, but it's only changes that are staged that get committed. The other files do not change in the commit if you don't add them to the staging area. So this guy's just changing stuff. This is what it looks like if you have multiple files and one of them is staged but the other one is not. So two of these files have been modified, and then one of them has been modified and staged. And once you stage them, then it's re-emphasizing this in the slides so many times because this is really important. And if you don't stage them, then you may lose your work. Yep.
By mistake, I have initialized a Git repository in my home directory. So how can I uninitialize it?
Just to make sure you don't delete anything important, I'm going to do that. The Git repo is probably really good because your home directory has a lot of stuff, so it indexed everything. But I just deleted the document directory and that cleans everything up. Yeah.
File created. When I add it,
Yeah. So that's because you haven't changed it. Right? So if you make some change, if you make a change, so adding it that will still work. Yeah. So but it didn't go past. So now just type some stuff. Changes to be committed and commit that. Okay. So this is how the workflow works. Once you add everything and it's all indexed by Git and ready, and you want to make the final snapshot, then you do git commit. At that, and git commit -m and give it a message just like we did before, and it'll be added to your log. Okay. So here's an overview of the workflow. You edit your files using whatever you use. If you use command line text editor, then Vim or Emacs, otherwise Sublime or Eclipse or whatever it is. Then add it status to make sure that everything is good. Always use git status because that'll tell you what's staged, what's not staged, what's been changed. So you'll know, like if you mess something up, you'll know immediately. When I was in 61B, Hilfinger said that apparently some people didn't run git status for the whole semester, and it turned out by the end of the semester that they had never turned in a single thing because they ran the wrong git commands. So run git status. All right. So I skipped over some Git internal database information because that's not really that important. If you guys are actually curious, you can ask me later. But so the next important thing is branches. And actually, before I move to this, let me just say a useful thing for using Git version control. Commit often because it's very cheap to commit. Git compresses everything very nicely, and you can commit lots and lots of times and it won't use too much extra data. So you should just commit a lot, because then you have lots of history, and if your code explodes and everything breaks and you're in like tears and at 3 a.m. and like, how do I get my code back? You have this long list of history and you can go to literally any time you want. And the Git automatically logs the time at which you committed everything. So you see, okay, this was at 2:59 a.m., this was at like 2:55 a.m., because that seems to be the likely times that everyone's coding. And that way, if you have lots of commits, then you won't run into a situation in which you wish you had your old code and don't have it. So the other thing that's cheap are branches. If you're making multiple features, as I was talking about before, then you may want to branch your code off so that you can work on different things at different times. You're required to commit everything before you switch to a branch, so you can't have changes that you've made but haven't staged and committed, because then Git gets very confused. So you're supposed to have a clean working directory, which means that everything that you've changed is committed and there's nothing in the staging area, there's nothing modified, it's just all nice and snapshotted. That way you can quickly move to another branch, as I was showing. Branches, if you know what a pointer is, branches are literally pointers. So branches are extremely cheap. All they do is they say this commit is a branch. It literally stores it as some tree, a tree in the structure, and trees are very cheap. If you've taken 61B or like know what trees are, they're very cheap, and you can make lots of branches if you are making lots of changes that you don't know if they'll work out. Because let's say you have a project and you decided you're gonna try it using like some class that you're writing, but you don't know if it's gonna work out, and you have to change lots of stuff to get it to work, and change your main function to call the class and all of that. But it turns out in the end that that all that work was pointless because it doesn't work anyway. You might want to go back to your other version. Then branching is very helpful for this. People look confused, so any questions? Okay. So git branch is the big command. Git branch and git checkout. So I already showed you guys this, branching and checking out, to switch between branches. Git branch will make a new branch if you put a name after it. When you just type git branch, it lists all the branches. But if you type git branch and then my new branch here, then it'll make a new branch called my new branch here. So this is what commits look like. They're just a series of commits. You can make a new branch called experiment using the command git branch experiment, and it'll just make another a branch, a literal branch on a tree off of this, so that you can make changes and you can do all sorts of stuff that's that you're making all these new commits. You're making all these new commits in your experiment, but you don't modify the original. So that way you can like work on a new feature and you can commit often, but then you can always switch back to your working stable code if you need to. So this is very useful in internships and stuff when you are working on code that is unstable, but you need to have a stable version that can always be used, and if you need to get back to a working version that you need to like give to a customer right now, you can easily go back to your original branch and say, okay, this one's working, you can take that. Because the experiment branches may have all sorts of crazy stuff in them that you're doing with bugs, but you can maintain a branch that like called stable or whatever you want, that you know it always works, and you're never gonna merge anything into that branch, which I'll talk about soon. That doesn't work. Yep.
So I can also get back to commit one in the experiment branch.
Yes. So if you're in the experiment branch and you want to go back to commit 1, then commit 1 is in a different branch, right? It's at a different level, and it's at a branch called master. That's the default branch. So if you do git checkout master, then it'll switch to where your main branch is.
So it makes going back more easy.
Yeah, much easier. But there's another feature of branches which I'm about to explain that makes, like, other than if this was the only thing in branches, it would be kind of useless. But this thing called merging makes things much more useful in branches. So does everyone see where we're at right now, or is anyone confused? Yep.
Can you just explain the git checkout a little bit?
Yeah, git checkout switches between one branch and another. So if you're at branch A and you want to go to branch B, you just type git checkout B.
So if you, at this stage, if you say your head is pointing to default, which is pointing to C4.
Head is just a notion for where you're currently at. So if you're currently inside the default branch, then head points to default.
Yeah, so right now, if you go browse through your repository, all of your code files will look like it does at C4. And if you run git checkout experiment, then head will jump down there, and then all of your files will look like it does at C3. You can just switch between them.
So this head points to the location in your whole commit history that your current working directory looks like. Because otherwise you would be completely lost and have no idea, like, which code am I looking at? Am I looking at yesterday's code, last month's code, today's code? So this head tells you where you are. Well, it tells Git where it is. You can find out where you are just by asking Git, by typing git branch, and it'll put a star next to the branch that you're currently visiting. So since I don't have too much time, I will go over this rather quickly. Git merge is the big command here. It is somewhat dangerous, so don't just type it willy-nilly. But basically what this does is, I'll explain before I move on in the slides. If you have these commands, or these commits here and those commits there, but now you've realized, oh, my experiment works. But I've also been having some stable changes that I'm making over here, because in my stable branch I found a bug and I wanted to fix it. But I've also been working on this experiment at the same time, separately over here, and now I want to merge all this together so that I can have both the changes from experiment and the changes from the master branch put together. Or in a more distributed terms, if you are working on some code and you're working on other code and I'm working on other code, all in the same project, then you can merge them all together and have your changes and my changes all put together into one piece of code at once. And this is why companies love it, because then they can assign, like, some developer over here to this part of the code and some developer over there to that part of the code, and then when they're done on their own personal branches, then they can put the branches together and all of their changes will coalesce into one code block or one code directory that just has everything there. Does that make sense to everyone?
Yes.
Anyone confused? I usually need to ask the inverse question. So merging does the following. So it will create this new commit 6. So you had commit 4 and commit 5, like this. You have your master branch and your experiment branch. And when you type git merge experiment, so if you're in the default branch and then you type git merge experiment, that means that I'm at the default branch and I'm going to merge in the experiment stuff to default. It's always pulling the stuff from the other branch into you, not the other way. You can only modify a branch that you're actually in right now. Yep.
Sorry, just to make sure. So does head automatically go whenever?
Yeah, head follows wherever you currently are, and you don't actually modify it yourself. You use the regular git commands, and head is just there for you to see where we currently are, because otherwise it would just be these commits and you don't know which one you're looking at. So that's just a pointer in this diagram so that you can see it. There is a real file called head, but it's inside .git, which you never need to look at. You can find where you really are by just typing git branch or if you want to look and see what the last commit was, you can type git log and see what the one at the top is. It's in reverse chronological order, so the latest commit is at the top.
Because I tried doing the checkout and it said had disconnected from.
What command did you type?
I just did git checkout and then I guess C1 or something. Or what the equivalent of.
If you check out a commit, you will be detached because you're supposed to check out a branch, not a commit. So you make a branch and then you can check out that branch. Branches are pointers to commits, but you're not supposed to usually check out a commit directly because then you're not connected to a branch. That's why it means head is detached state, because head usually points to a branch and says, okay, I'm currently on experiment branch or I'm on default branch. You can make head point to one of these directly, but that makes things confusing where you get a head detached state, which sounds like you're headless, but
So how do you create a branch to a specific commit? Not the one you're on?
you can do git checkout minus b, which just means both create the branch and check it out at the same time, and then the name of the branch. And if you just ran that, that'll check out. That'll make a copy of your current branch and make that into another branch. But if you put a name after that or a commit number after that, then it'll make a branch that points to something else. If you didn't understand that, don't worry about it because I was just answering that specific question. You don't usually need to do that. So anyway, back to merging. If you want to coalesce all these commits together, then you'll want to create another commit, and the way that you do this is just type git merge and then the name of the branch that you want to merge into your current branch. So you're on default, and some code partner was writing a bunch of code in experiment, and you want to merge their code into yours. You can just type git merge experiment, and all of their experiment code will merge to you. And this is what it'll look like. The commit 6 doesn't just have one parent, like commit 5 only has commit 3 as its parent, and commit 3's parent is C2, and commit 2's parent is C1. But if you're merging, then you have two parents because you're taking this entire list of commits and that entire list of commits and putting them together. And parent just means what commit did I come from. But this guy came from two commits, both C4 and C5. And once you've merged, now you have all of that stuff merged into default, and the default branch has all the code in it. And you can keep doing this as much as you want. I'm not going to do three-way merges because that's not useful. Okay. This is somewhat useful. So if you have your local repo and you have on the internet, you have some repository like GitHub, then you'll need to use git push, and git fetch would work, but git pull also is usually what's used. Git push is like if you're in 61B or other class, you'll probably turn in your code this way by pushing it. So that just takes all of the commits you have and sends it to the repository that's on the internet, and it copies all of the commits there. And that way they have a copy of the entire history just like you do. And git pull does the opposite, where you copy all the commits they have. I'm not going to really go over multiple.
What's the difference between pull and clone?
Clone makes a copy of a repository and gives you the whole thing. Pull is if you already have a copy of the repository but you want to update it with new changes, then you do pull. So if you already are working on a project, not that you don't want to download a whole new copy of it, you only want the changes. So git pull will only download the differences, the new commits that have been made in the interim.
So it overrides.
It won't overwrite your changes because you can't pull unless you've committed, and that way your commits are already snapshotted, so it won't overwrite anything.
So you won't lose anything?
No, you won't lose anything as long because it won't let you pull if you have any modifications that you haven't committed.
So after you pull, your code looks like exactly what it.
It looks like the merge between. It's basically like merging their branch into your branch. their copy of branch A and your copy of branch A, they're the same branch, but theirs has different commits than yours because you haven't synced up yet. So when you pull, then it'll merge their commits with your commits. And then the last thing I want to go over, so we only have 10 minutes, is merge conflicts, because you will actually have to deal with this in real life. Huh? Same. Let me find it. As you can see, there are hundreds of slides, so I could have made this go on for 5 hours, but but apparently the slides don't talk about merging to merge. Yeah, okay. The slides don't even have that, but anyway, I'll go over this slide because this is kind of useful. When we post all of this, then you'll be able to see this is basically a list of every important command. Other than this, you don't need anything. And since apparently these slides did not have merge conflicts, I will go over them manually. I have not given this particular talk for several years, so. Oh, my computer is frozen now. That's probably going to Southside. So this, you guys should also look at this on your own time. The Git website has very useful documentation that is very simple, and when I first learned Git, this is how I learned it. They have some similar diagrams to what I was showing, but one thing that is really important for everyone to know is merge conflicts, which is when you make a change and either you make one change in one branch and on another branch you make a change in the same file, or alright, here's merge conflict. Or someone else was editing on their computer and you were editing on yours, and then you pulled and their changes conflict with yours, then you'll have a merge conflict. So this is what it looks like. I'll zoom in a bunch. So if you change the same part of the same file differently in two branches, then it's not going to know which one to pick. If you changed, like if the three of us were working on a project and you changed file A, you changed file B, and I changed file C, that's easy. You just use your copy of the file that you changed, and that's all. But if we're all working on one file and made changes to the same line of code, it's not going to know which one to pick. So it'll tell you this. When you run the merge command, it'll say auto merging. Auto merging is its algorithm, and then it'll say conflict and merge conflict in whatever file. And then this is a little bit difficult to create quickly. It's to create your own merge conflict to show you guys. So when you actually run into this situation, you will probably want to look back at this documentation. I still do because I don't want to mess my code up. So it will tell you this. You have unmerged paths. This file has been modified in both branches that you're trying to merge together, and it'll warn you, and it'll list all of them right here. Then in the file, it'll look like this, and it'll show in the current, head means where you currently are, so in the current branch, you put this, but in the other branch, you put this. And then you just have to delete this line and all the stuff that get inserted in here so you could find the merge conflict easily. It actually modifies the file and inserts this so you can see it. And then you need to go in and choose one of them and delete all the other stuff. You'll have to let's say I wanted to choose this version, then I would have to delete all of this. Oops. I would have to, okay, what is happening? I would have to delete all of this and delete this, and then leave it with just this version of the code. And once I've done that, then I'll have to manually, where is it? Here, manually do a commit, and that will basically tell Git, okay, I'm done fixing all the merge conflicts. I don't have any more left. You can check that with git status that all your merge conflicts are resolved, and then you commit it to say finish the merge. Normally you don't have to commit when you do a merge because it'll make one automatically, but if you had merge conflicts, you'll have to tell Git when you're done fixing all the conflicts because it won't know for sure when you're ready to make sure that all the branches merge together properly. Okay, that was the last topic. So any questions about anything about Git at this point? Or if you were confused about anything?
Can you explain again how we check where the conflicts are?
Yeah, so when you have a merge conflict, once you've run the merge command and it says conflict, it'll list all of the files right here for convenience, and it'll also list it in git status, unmerged paths. And then inside the file, it'll insert this stuff. So if you had, if this one is what branch A had in it, and this one is what branch B had in it, it'll put both of them with a couple of like equal signs and a bunch of less than signs so that you can easily find it in a file. You can like Control F for that, and then it'll tell you, well, in where you currently are, this is what you have, and in branch ISS 53, you have this. And you'll easily be able to see it. And you just fix it up to however you want it, do git add to stage it, and then do git commit to finally merge it. Does that make sense to you and to everyone else? Any other final questions? How many of you think that from this information you could use Git or reasonably figure out what you're doing in Git on a project? Okay. For those who didn't, is there something specific that you don't understand?